So this recording is about how to use Matlab to solve a resultant force for a 2D problem. The first thing that you do, you would come to octaveonline.net, then you can click on menu, login here, sign in. So after you sign in with your Google or Hotmail, you can create a new file. So click on this, create a new file. When you create a new file, make sure that you keep that .m in there. You can put the name. Also, don't put the space in your name. And don't put very long names either. So after you create the file, you can delete the content of your file, put CLC clear on the top of your program. Then you can start doing your programming. So in this case, I want to have like F1. So I'm going to tell the computer F1 is equal to 150 and F2 is equal to 300. So where I get these values, I'm bringing these values from the question I have. So the question I have in the tutorial is there are two people, they are applying forces on this, one with the angle of 20, the other one with the angle of 70. So I have F1 is equal to 50, F2 is equal to 300. Now F1x. So F1x would be equal to, we already know, like we need to put like what's the angle for the first one. I'm going to call angle or theta. We just call it ANG. Angle 1 for the first force is 20 degrees. Angle for the second force is 70. So F1x was cosine, right? Was because the angle is with the x-axis. In the program, we say both angle with the x-axis. So x would be the adjacent. So I'm going to say would be F1x times cosine of angle 1. Now, where I make the mistake here, I make the mistake. Yes, please.
So just F1?
Yeah. So this will be F1. That's right. So the other mistake I made is that I put here angle 1 is equal to 20, but that's 20 degree. The cosine function in Matlab use radian. Same thing in Excel, any other programming. They don't use this. So what I need to do, I need to convert this angle from degree to radian. So there is another function in Matlab that can do degree to radian for me. So I'm going to say degree to radian of angle 1. So I'm done with this. So I'm going to say F1y is equal to F1 times sine of, I'm going to copy from what I have there. Get 1. So I can find F1x, F1y. Then I can copy this, rename it for F2x, F2y, right? So I'm going to just rename this as F2, rename this as F2, rename this 2 to F2. Then this will be angle 2. And then I also need to change the angle here to 2. So I can actually run it and can see whether it's working right now or not. So every time you have to hit save and run. Save, run. It did the calculation for me. So F1x is 140, F1y is 51. It did the calculation for F1x, F1y. Now I want to find FR. So I'm going to say FRX is equal to F. I have to use the same, like I have to respect the capital letter and small letter. So F1x plus F2x. I can copy this and then change the x to y. I'll repeat that. And then I'm going to say FR is equal to SQRT, stands for square root of FRX to the power of 2 plus FR y to the power of 2. Right now I'm finding the resultant of those two, and I can find the theta. The theta is equal to tan inverse. It stands for a tan. A tan meaning tan inverse of fry divided by frx, and I'm kind of done. So remember what I'm doing right now. I'm actually following all the equation I talk about into the lecture. So if we just look into this, we find the f1x, y, and then 2f2x, f2y. Then we find the frx, fry, which was the summation of those. The resultant force is the square root of that. And then the theta, the angle with the x-axis, is tan inverse of fry over frx. So that's actually what I'm following. Okay, so I found the theta. The only issue I have, the theta that give me, this is already in radian. I have to convert it to degree. So I'm going to say theta is equal to, this time I have to go from radian to degree. Radian to degree of the theta. So save and run. It did not run the very recent one. Okay, it did calculate, right? So your resultant force is 412 and the angle is 53.835. So this is the code I wrote for two forces, and then I want to check the tutorial what I got the answer from there, whether I got the same answer or not. Yeah, I got the same answer. This is like 53, 412. But the problem with my code is that for two forces, I write so much stuff. I don't want to do all this work. This is too much work. So what I could do, I could create a loop. If I have like n number of forces, it would be able to repeat it for that n number of forces. And this is actually the code for that.